This is another one of our videos with stupid titles. We'll keep it as short as possible. This video is more about explaining buoyancy than actual fish, so let's get started. While fish can swim perfectly in any direction, they can't really swim up and down. Even if they could, they would sink down. Why is that? Because they are denser than the water around them. But what if they could lower their density? How can they do that? Simple. The formula for density is as follows. Density equals mass divided by volume. So, from this equation, you can see that increasing the volume increases the number that we're dividing with and therefore decreasing density. So, if two objects with the same mass have different volumes, the one with a larger volume has a smaller density. Think of it as an amount of stuff you can put in a certain place. Now, imagine a balloon. What would happen if you threw it while it is deflated? Yes, it would fall down. When you inflate it, you increase the volume and make it less dense, so it takes longer for it to fall down. Fish have swim bladders. You can think of them like balloons inside their bodies that they inflate or deflate, changing their density. Now, let's talk buoyancy. Imagine a ship on the water. It will float only if it displaces the amount of water that is equal to its mass. Just by changing the part of the ship that is underwater, you can change how high it floats above the water. Since fish don't float on the surface of the water, we'll have to see what happens when an object is fully immersed in the water. Imagine this. We throw a metal ball in the water. It starts sinking. Gravity is pulling it down and buoyancy is pulling it up. Now, imagine the ocean. Let's split it into layers. All the mass from the layer number 1 is resting on layer number 2. All the mass from layer number 2 is resting on layer number 3, etc. That means that layer number 5 is supporting all the mass from all the layers above it. I know that they taught you that water is incompressible, but they lied. Water is treated as being incompressible when doing math, but it does have a little bit of compressibility. Also, denser water sinks in less dense water and collects at the bottom. Water at the bottom is also a bit colder and makes it even more dense. So as you go down, the water becomes denser and denser. Now, let's get back to our metal ball. As it is sinking, the buoyant force becomes larger and larger. At some point, it is the same as the force of gravity and they cancel each other out. But what does this have to do with Zeppelins, I hear you shout? Well, Zeppelins work exactly the same way. You can imagine air as a fluid, even though it's not. It behaves almost the same. The mass of air rests on air, which rests on air, etc. That's why plane cabins are under pressure, because the air at high altitudes is at low pressure. Let's not keep this video too long and end it right there. If you have any questions, leave them in the comments. Thanks for watching. Like and share if you thought the video was good, and consider subscribing. Bye.